Okay, today I will be delighted to take you on a journey about the product I've been working together with my team for a couple of years. Long story short, the product is based on Elasticsearch to do cache for large amounts of data. Let's go. Okay, let's take a look at the agenda of this presentation. At first, I will give a few words about our motivation for creating such a system and how we constructed our team in order to achieve it. Then we will deep dive into the architecture. The darkest place is always under the candlestick, so I will explain how synchronization works in our multi-cluster system. We wanted our system to work even after failure. I will explain our failover strategy and our motivation to use it. Then I will take you to on often underestimated place performance. You will see why we were drowning and who were there to save us. Last but not least, we will talk about the problems we encounter. Okay. This is my favorite quote. I even use it to finish my Matura exam. You all know that not all the IT projects end up successfully. They are oftentimes like a proverbial box of chocolates. They may look delicious and even taste great, but you never know when you end up with a stomachache or diarrhea. Okay, our application eventually turned out to be a success, but the road was not a bed of roses. Okay, why we did what we did? Okay, it's simple. We wanted to have an amazing system for our customers, to give them what they require in our banking system and in our branches, stability and performance. Okay, here are 5 points that were our goals: quick writing and sharing. Okay, we want everything in our lives to be available almost instantly: food, taxi, movies, money, and other stuff, which we probably shouldn't mention here. The other point, high availability. Okay, if you create an application for a client, especially related to the client's money, it must work all the time. Okay, easy. Scalability. If you create cache, you must be sure that it will last for longer periods of time. If you constantly gather data, draw on traffic, one server solution is not for you. Okay, another one, data synchronization. If you gather data from multiple systems in real time and can't afford data loss, you must work on synchronization. It was a tricky part. And the last one, migration from outsourced solutions. Our system had to work for our online and banking system and also internal systems as well. We had to deal with migration procedures. So we had to adapt for functionalities and API for other systems. Okay, what do you do when you don't know how to answer a question? Okay, you ask Google, documentation, support, IT teammates, not always in this order. What we did is we formed a team of experts to create our application. At first, we hired a company of experts with experience in Elasticsearch technology. Then we formed an internal team for development. We also bought support from the producer. Okay, and now I would like to tell you something about the Elasticsearch support. It is different than the other supports. They want to help you with your problem and they want your product to work perfectly. Our first contact with them was after the first launch of our application for a limited number of clients, sort of friends and family. We discovered that our reply times were not quite what we expected. We filled the form with a lot of technical data. The support contacted us by teleconference, and the guy on the phone was shouting at us why we came to them so late. Okay, the problem with Elastic support is that they like to iron our flaws at the beginning when the solution is discussed, and we didn't do it. They helped us, of course, with the issue and elaborated on the things that needed to change in the future. From then on, they contacted us every few months to check how we perform. They asked for statistics and analyzed them for that. What supports do that? Okay. Okay, it's time for some juice. We're gonna deep dive into architecture. Okay. Great. Okay. The central cache architecture supports text search and query engine for sensitive data, which is mostly Elasticsearch. Writing data types in synchronization with master servers. It is the tricky part. Let's have a look at the picture. Okay, the first part is as usual. Clients enter our system through a load balancer. Then we have an application that reads data from the clusters. Okay, the heart of our system consists of 3 independent clusters, 2 Elasticsearch and 1 Oracle. We have a separate application for writing into them. So every application writes to its own cluster. Then there is component to notify other application about some events. Okay, the supplier for our application is Q system. And there is also Redis used as a shared memory system. Okay, so let's go and let's talk about Elasticsearch and Oracle. Every Elasticsearch cluster is built from 5 nodes. We have 160 cores at our disposal. The best part of Elasticsearch is scalability. If you prepare good indexes and you can scale up the infrastructure horizontally to meet your performance demands. The clusters don't communicate with each other. You can see that. No. Okay. And if one cluster fails, the other has enough power to perform normal operations. Every cluster has the same data inside. We will talk about cluster synchronization in the next chapter. There is one difference between Oracle and Elasticsearch. We cannot perform the same operations on them. For example, text search. But we will cover the differences a bit later. Okay. The data reader is the most important part in the system. And it is my favorite component. It is responsible for sharing the data with the other systems through REST API. It uses all clusters in order to gather the required information. And this layer is based on failover and balancer logic, which I will describe in detail later, of course. Okay, data writer is the second most important component in the system. It is responsible for writing all the data into every cluster as soon as possible. Okay. It is also responsible for finding and repairing data loss, and if necessary, call for a transmission of some data sets. And also responsible for producing technical data into the queue dedicated for the data messenger process. Okay, now the tricky part. One instance of data writer is responsible for one cluster. Thanks to that, we can shut down, upgrade one cluster at the time without service downtime. It's very, very important if you share the system in banking. Okay, and every data writer instance has its own independent pair of queues. Intentionally, we don't use topics. We can call for single package retransmission and all packages retransmission. It is more than 5 billion documents, so it will take a lot of time. Okay, okay. Let's take a look at the sequence of operations on the data writer. At first, the other system has to generate data and construct a package. Then the package is sent to queue system, then the package is received by the data writer, and the data writer is processing information, and information is written into Elasticsearch or Oracle. The next step, the next step needs some clarification. On the Oracle database, we have created a journal for every cluster. It is a place where we put information after the successful write of the package into the cluster. The last step made by the data writer is to send technical data into the queue for further processing by the data messenger component. Okay. Data messenger component is important, but not a critical element of the system. It is used to send some technical information to other systems. For example, new data has been written. Please refresh your internal cache. Okay. And there is a pipeline for data messenger. First, we have two different scenarios. Okay. The first scenario, wait for all clusters to finish their work on the package and send notification. For example, let's imagine that we have a process starting instantly after writing complete data into all clusters. If you can't ensure the proper sequence of the task, the process will eventually fail. Okay, and the second task, send notification instantly after receiving data on the queue. So if you write to one cluster, you send the notification. Let's think of the process where you need to verify if the data has been written into just one cluster and then start some operation. Everything depends on the chosen scenario for the data. Great. Okay, are you sleepy? No? Then let's begin the next chapter where I will focus on the synchronization mechanism. It is the most important part of our solution. It ensures the completeness of the data inside. Okay, let's look at the package structure. It is a simple object built on the XML format. The package includes the header and the data inside a list. So we can have a lot of objects in one package. Okay. Every network protocol has a header inside the package. We have a sequence and acknowledge number on the TCP protocol, content length value for HTTP, and many others. We also need some contracts to communicate in our protocol. So inside the header, you will find few attributes. Okay, in the field current pack date, we have a date of the package. This the same date as the date of the data. There is also current pack ID. It is a sequence number with information what is the current package number in the date pointed by the current pack date. There is also previous pack date and previous pack ID, which point us to the package just before the current package. Okay. There is also a quantity, which is the number of an object inside the package list, number of objects. Okay, so we have 1, 2, and 3. So quantity is 3. Okay. Lastly, there are dates for generation and send time. Okay. Okay. In our system exists a concept of a journal. It consists of information about every package. You can find there all the fields from the header. we also put there a status of writing the data into Elasticsearch or DB, because you can write the data completely or not. Or you can also miss the data, so there won't be any information in the journal. There is a process looking for inconsistency in the journal. If one found, it calls for retransmission. Why do we need to retransmit the package? There are two cases. You didn't receive it, or it is broken by enemies. Okay, please look at the retransmission message. It is a simple structure with two values, current pack date and current pack ID. So we can say, okay, we didn't receive this package, or this package is broken, please send it once more time. Okay. Okay, the data. Okay, without the header, there wouldn't be a package, but without the data inside, there wouldn't be an application. Okay, in the data section, you put all the information you want to have in your cache. As usual, there are some limitations. There has to be some unique key to identify the document. In our example, the unique key is personal ID. Not always the unique key is so obvious. Sometimes you must think for a while. Okay. We have two different types of synchronization. One used for documents that are not changing in time, and the other that are changing in time. We use the optional key name action for the documents modified in time. There are two types of operation to be performed. Update means insert or update already existing data. Delete, remove existing data and set the tombstone. Okay, how do we deal with the data updates? Please don't think about the update as an SQL update. In our system, this operation is a little different. Let's check the scenario on the slide. Suppose we have two different packages. The first one is older than the second one. You see, current pack date. Okay, let's imagine that for some reason, the second package was written before the first one. Okay, when the first one is processed, it gets a lower version for the document. Okay, Elastic knows that there is already a document with a higher version. Okay, there is a comparison inside Elasticsearch. So the older one will not get written into the index. This is good. The idea is to specify a version for every document. So you have to imagine how you build the version number in order to achieve what you want. Only documents with the highest version can exist in Elasticsearch or Oracle. Document version can be related to the package number, but it can be something else. It's up to you. The tombstones. When the document is being deleted, we usually have a limited amount of information about it. But for sure, we don't want to use it in the future. The delete operation on the document is almost the same as an update, almost. We created a mechanism called the tombstone to mark the document as deleted. The solution is easy. Write the document with the primary key, version number, and the field deleted set to true. So that's why our search algorithms ignore every document with the field deleted set to true. But it's not so easy. Okay, I named this part failover, but apparently this is more than that. In this chapter, I will talk about load balance, failover, and health check. Okay, you can have different load balance techniques on the different layers. So let's go how we do it in our system. At the top, we have a load balancer or service discovery with a balancer inside the client application. It is the easiest part. Next, we have a data reader application that can switch from one cluster to another. There are some rules. We can switch between active Elasticsearch clusters. We don't route traffic to the Oracle cluster when one Elastic cluster is operational. Okay. How do we choose the cluster? We have three types of routing. Session aware. So every query from one session goes to the same cluster. It is not a cache session. It is application session. So the application have to give us the information. Yes, this is this session. So please put me into the same Elasticsearch to the same cluster. Okay. There is also another strategy, active passive. Only one destination is active at the time. And there is also the third strategy, force cluster. We can force the task to be executed on the indicated cluster. It is only used for diagnostics only. Okay, so designing this type of application is a process of learning new tools. So we eventually learned what consistency means in practice. Data written into Elasticsearch is eventually consistent. But what if you have more than one active cluster? Wow, one tester made some changes and tried to check data from two different sessions. The first one, the data was available, okay? But on the other not. That's why for some processes we don't use session-aware routing. Okay, at last, the query is executed on the Elasticsearch cluster. There is a magic behind the doors, so I will talk about it. Every index on Elastic, it is sort of a table on SQL database. Is made of shards. Okay, we have a lot of shards. Every shard has some part of the data and can have multiple duplicates. So you don't have to have duplicates, but it's very good to have some. And we can point query to go into specific shard or to search full index, which is very ineffective. If we have many nodes, we can duplicate shards to use different machines for a query. It's very effective, but you have to test it for yourself. Okay, health check. Health check is an important part of the failover mechanism. We have different use cases for it, and the first one, URL for availability check of the data reader application. This is an easy use case of the web applications. The next one is much more complicated. It is the process inside the data reader application to check if the cluster is working correctly. Inside the application, the cluster can have different statuses. For example, one of the indexes or shards is invalid. We have to operate on, we have to use only healthy indexes because we want to have all the data. We don't want to have part of the data. Okay, so the other stuff, the cluster is not responding. For example, because of the network issues, hardware issues, and we can't use the cluster. Okay, on the slide there is a structure of health check information we are gathering. The data reader uses it to check if the query can be executed on the cluster. If not, it will automatically switch to a different source. Okay, so you can see that if the cluster is down, or if we force the cluster to be disabled, because we can do it. It's a very nice feature. Okay. We have different failover scenarios in our application. The first one, data reader node is down. Okay, so if the data reader node is down, we will switch to another one. Easy peasy. That's what the load balancer is for. The other one Elastic cluster is failing. Okay, so if the Elasticsearch cluster is failing, we will see that the cluster is down. Is down will be true. Okay, so we will switch to another cluster. Okay, but we can have another scenario. Two Elastic clusters are failing. So if they are failing, we have to switch to Oracle cluster. I have to say that our infrastructure consists of two different data centers. One Elastic cluster is in one data center, and the other Elastic cluster is in the other data center. But our Oracle cluster can be in one data center or the other data center. So if we have multiple failures, we can switch our Oracle between the data centers. Okay, but this is when we switch to Oracle cluster. This is the first use case when we degrade our functionality, because text search and field search won't be available in Oracle cluster mode. Okay, and the other scenario, all clusters are down. Okay, it's not very good, but our application, if the clusters are down, sending special information, okay, data is unavailable. Okay, we can have all data readers down. So our load balancer also have the proper information, and it can send the reply for every query with information, oh, sorry, data is unavailable, so go away and do something else. And also we can have load balancer down, and this is a classic fail and over scenario, my favorite. Okay. Okay. The best place to fix errors is the production environment. Who agrees? Me? This is controversial, but how true? Okay. At the start, we had 3 different applications interested in our functionality. 1 in production already, and 2 in the tests phase. Okay. At first, we have integrated our system with a very new solution for our branches. In beta test, we saw that there is something wrong with our performance. Times for our sorting operations skyrocketed. It was the first time we called for help from the support. The first contact was very unpleasant. The guy on the other side was unhappy trying to solve the production problems on the system he doesn't know. He reacted just like this poor animal when I wanted to take a photo. Fortunately, the second contact was much better. We prepared many diagnostics data. Support guy helped us with many ideas for the future use. Okay, the solution was simple. Don't use _ ID for sorting operations because it was not prepared for this kind of scenario. So we defined our field inside the document, and that was it. Easy peasy, but you have to recreate the index, so it will take a lot of time if you have 5 billion documents. Okay. Independently of our integration tests, we started our trip to stress test our application. One of our goals was to replace an existing application with that was under very heavy load. It was a very good starting position, I must say. Looking at the log files, we knew what customers were searching for, filtering, etc. So we gather all the usual use cases from production and prepare the test scenarios. So you can see that we at the start we had a lot of data. It's more now. It's more than that, and in the next year it will be much more. So there are the test cases, and we built the application to test the scenarios. The idea was to test our application in production conditions. We have gathered about 50,000 samples of queries executed on the original solution. Next, we put them into a mixing mechanism and use them for testing. The first encounter wasn't as good as we expected. We had to use the Elasticsearch profiler to check our queries. I must say that there are two optimization mechanisms worth mentioning: explain plan and avoir reports on the Oracle database, and Elasticsearch profiler. The results after changes were very promising. Okay. And we tested different configurations for our indices and selected optimal for our system, because we had to deal with how many shards we want to have in our indexes and how to route the data and so on. So you have to test. There is no ideal solution. You have to check it for yourself for your application. And you can look at the results just before the Big Bang. Okay, and these are the results of aggregation between 4 different indices. Okay, so now we'll talk about problems you know. How many projects have you finished on time without issues or major delays? Okay, time helps us learn about the issues in our projects, which is usually hard in the early stage. When we work, we make mistakes, period. The most important part is to learn from them. We tested the solution and produced several tasks for the future. Okay. We optimistically implemented both search after and pagination algorithms. For short indexes with a few millions of data, this is not an issue. When a search after is memory safe, pagination is very heavy on memory usage. On the pilot stage, we learned that what this very heavy memory usage means. Some applications tried to use pagination to iterate through dataset more than 10,000 documents. It was a classic failure because 10,000 is the lot default limit for Elasticsearch. Of course, you can change the limit, but it will cost you a lot of memory. Pagination is easy to use for a few pages, but iteration should be implemented on the search after algorithm. So, first lesson. Our implementation is based on many indexes, but one is very, very big. With every context from our support, we collect WIPs because of it. We must split it into time-based indices in the future. The task will take a lot of development and time with our support, of course. Okay. And the last one, if you create the tombstones, I said that it's not easy. If you create the tombstones, sometimes you don't have proper values for the correct routing into shards. Okay, so finally you must put the tombstone into every shard. More shards equals more tombstones and more memory usage. If you have almost the same amount of delete and update operations, this is a problem. It means your index has much more documents with the deleted flag set to true than false. The task is not so trivial, but can be solved. You must develop a vacuuming process based on the journal. These tasks are before us. Okay. Are you sleeping? I hope you enjoyed my presentation. Now I must use magic words. Hi Studio, the power is yours.